Who are our helpers today?
Caleb!
And?
Ryan!
Fryer! This stuff is called Tang. You guys are each going to take 3 scoops of Tang and put them into your container. 1. Good. 2. Okay, that's good for you, Briar. Now, let's take this cup, pour it in.
It turned orange.
Turn orange. Okay, mix it up with your spoon. There's your spoon right there.
Oh, yeah.
Mix, mix, mix. Mix, mix, mix. What numbers is it by?
150.
Okay, that means 150 milliliters. Have a sip. Tell me what it tastes like. Do you want me to take them off for a minute?
Yeah.
Okay.
My eye is help.
Okay, you too.
My milk.
What does it taste like?
Yummy orange juice.
Is it sweet?
Yes.
Is it very sweet or not very sweet?
Super duper duper sweet.
Okay, good. Now, let's take this big cup. Pour that whole cup in. Pour, pour, pour. What numbers is it by over here?
500.
500. So there's a lot more water in here now, right? Okay, give it another little stir. Now, Caleb, did we add any Tang? Did we add more of this stuff?
No.
Did we take any away?
No.
No. Okay, now let's take another sip.
Viper?
What does it taste like? Is it as sweet as it was before?
No, it almost tastes like regular water.
Oh, okay. So when we added more water, even though we didn't add more of this stuff or take any of it away, it tastes less sweet. Thanks, guys. Thanks for your help. Do you know what you just did? It's called a dilution. Can you say dilution?
Dilution.
Good job, buddy. Thank you for helping. Thanks, guys. Can you say dilution?
Yeah.
So let's look at a solution. We have 5 moles of solute in 500 milliliters of solvent. And so our total solution volume is 500 milliliters. We're going to represent our 5 moles by these 5 little molecules here, right? So this is my solute. And we could calculate the concentration, C equals N over V. So we have 5 moles in 500 milliliters, so that's 0.5 liters. So the concentration is 10 moles per liter in this beaker here. Now, let's imagine that we add some more solvent. So we're going to add 500 milliliters more solvent to bring our total solvent volume up to 1,000 milliliters, or 1 liter. So if we do that, but that's the only change that we make, right? We've added 500 milliliters more to get 1,000 total. We haven't added any solute. We haven't taken any solute away. We're still going to have 1, 2, 3, 4, 5 moles of solute. And that fact is going to be very important when I start doing some calculations. Because when I dilute something, I'm never changing the amount of solute. Right? The amount of solute stays the same. So I can calculate the concentration here again, C equals N over V. Now I still have 5 moles of solute, but now I have 1 liter of solution, 1,000 milliliters, or 1 liter of solution. So my new concentration is 5 moles per liter, right? I've added twice as much solvent, so now I'm half as concentrated as I was before. And keeping in mind the fact that the number of moles stays the same before and after the dilution, right? This here was before, or this was my initial concentration. This was my after, and we're going to call that the final concentration. And I want to keep in mind that my N stayed the same. The number of moles of solute stayed the same. Concentration changed, started at 10, ended at 5. My total volume of solution changed, started at 0.5, ended at 1. But my number of moles of solute stayed the same. So I can use that to build a formula. So to derive my formula here, I'm going to add some unique indicators. Instead of just calling this a C, let's call it a CI because it's my initial concentration. And instead of a V, let's call this a VI because it's my initial volume. And this was my final concentration and my final volume. So let's call that a CF and a VF. And so then I actually have two formulas, right? I have CI equals N over VI. The N doesn't need an I because it stays the same. And I have a CF that's the same. Now, if I can set this formula equal to N so that N is by itself, then I could substitute N into the other formula. And I can actually use these to build just one formula. So let's do that. If I want to get N by itself here, well, I have to get the VI out of there. I can multiply by VI on the right. Do the same thing to the other side. And that gives me N is equal to VI times CI. And then the manipulation is going to be the same over here, right? If I start with my CF equals N over VF, well, I multiply by VF on both sides. And that gives me N equals VF times CF. And so what I can do then is I can take this N here and I can substitute it in for this N over here and build just one formula. So then when we do that, my CI times my VI will be equal to my CF times my VF. And then that's going to be my formula. So this is my dilution formula. CI VI is equal to CF times VF, where my CI is my initial concentration, my VI is my initial volume, my CF is my final concentration, and my VF is my final volume. Now, you're going to ask about units. So what kind of units can I use here? Well, you can use whatever unit you want for concentration, as long as it's a concentration unit. Often we'll do these in moles per liter because we're chemists and we like those units. But this will work for percent concentration too. It would work for a part per million concentration, any concentration unit that you want. The thing that you have to watch though is that whatever concentration unit you use on the initial side, it must match the concentration unit that you use on the final side. So if you use moles per liter on the initial side, you have to use moles per liter on the final side. Or if you're looking for CF, then you have to be aware that whatever you plug in on the left is what's going to come out on the right. So your initial concentration, if you put it in moles per liter, it's going to come out, if you're looking for your CF, it's going to come out in moles per liter as well. And we'll look at our first example why that happens with the units. Same thing is true for your volume. You can use whatever volume you want, whatever volume units you want. We often use milliliters or liters because those are convenient, but you could use hectoliters or gallons or picoliters or whatever you want. But again, it's got to match. So whatever you use on the initial side, it's got to match what's coming out on the final side. So let's take a look at an example. 40 milliliters of 3.4 molar sodium chloride aqueous solution is diluted to a final volume of 200 milliliters. What's the amount concentration of the final solution? Okay, so first thing I want to remember is this capital M molar, that's the same thing as moles per liter. That's our shorthand for moles per liter. So that's a concentration. And sometimes people have difficulty picking out values from these questions. So you want to be able to think about, what did it look like before? What was my initial state? What did it look like after? What was the final state? And this is telling me that I'm starting with 40 milliliters of 3.4 moles per liter solution. So this is a volume. I can tell it's a volume because it's got volume units. And this is my initial volume. So my initial volume is 40 milliliters, and this is my initial concentration, 3.4 moles per liter, 3.4 molar. I diluted it to a final volume of 200 milliliters. Again, it's got volume units, so I can tell that's my VF, 200 milliliters. And then I'm looking for my final concentration. What is the amount concentration? And it tells me what units I'm looking for, right? But I would also be aware that because I'm plugging in molar on my CI, my CF is going to come out in units of moles per liter as well. So I've picked out my variables. Let's look at my formula. CI times VI is equal to CF times VF. I'm looking for CF, so I have to get it by itself. The thing keeping CF from being by itself is VF. Can divide by VF, that will cause it to cancel over here. If I divide by VF on one side though, I must divide by VF on the other side as well. So now this is my new formula. CF is equal to CI times VI divided by VF. Now we can plug in my numbers, and this is why you want to pick out your numbers, because it's really easy to put a volume in the wrong spot unless you've clearly identified what's what. So my CI was 3.4 molar. My VI was 40 milliliters. You don't need to turn that into liters as long as my milliliters, as long as my units match, right? My I and my F match, so I don't need to convert that. Then we're going to divide by 200 milliliters here, which will give me my CF. So 3.4 times 40 divided by 200 is 0.068, and we need units on here. We can't leave this as a naked number, so 0.068. What are the units going to come out as? Well, my formula actually tells me. So I've got molar here, and then I've got milliliters divided by milliliters. And remember, units cancel just like variables. So if I have milliliters on the top and milliliters on the bottom, they will cancel. The only unit that's left here is a unit of moles. So that's why this guy comes out in moles. I checked my sig digs. I've got 2, 2, 3. So I have to report this to 2 sig digs. These zeros are not significant, so these are. So I already have this to 2 sig digs. That means this is my final answer. So my final concentration of my sodium chloride solution will be 0.068 moles per liter. Let's try another example. A lab technique needs to use a stock bottle of 16 mole per liter sulfuric acid to prepare 500 milliliters of 1 mole per liter solution by dilution. What volume of the original should be used? This is probably the most common way that you would actually use this formula if you're a chemist. You often need to do this. Take a more concentrated solution. You want to make a certain volume of less concentrated solution, and then figure out how much do you have to take of the original stuff. So let's pick up my values first of all. I know that I'm looking for initial concentration, initial volume, final concentration, and final volume. So I should be able to find 3 of these values in my question. So I have a concentration here. This is my stock bottle that I'm starting with. So this is my initial concentration. I want to prepare 500 milliliters of 1 mole per liter solution by dilution. So this is how much I want to make. So this isn't my initial volume. This is my final volume. And this is my final concentration. What volume of the original should be used? So I'm looking for my VI. So that's what I'm trying to solve for. My initial concentration was 16 moles per liter. My final concentration was 1 mole per liter, and my final volume was 500 milliliters. So let's look at my formula. CI times VI equals CF times VF. I want to get VI by itself. So to get VI by itself, I have to get CI out of there, divide by CI, divide by CI. Those guys will cancel. And that leaves me with VI equals CF times VF divided by CI. So now I can plug in. My CF was 1 mole per liter. My VF was 500 milliliters. And my CI was 16 moles per liter. So when I multiply these out, divide by 16, I get 31.25. Now the units here, I've got moles per liter divided by moles per liter, so those cancel. The unit that's left is going to be milliliters, so it doesn't come out in liters. I plugged in milliliters as a volume unit, so I get milliliters out. And then I just need to watch my sig digs. I'm only permitted 2 sig digs here, so my VI will be 31 milliliters. So to prepare my new solution from my stock solution, I need to take 31 milliliters of my original solution. Let's try one more. So 30 milliliters of 0.15 mole per liter glucose. Let's try one more. 30 milliliters of 0.15. Let's try one more. 30 milliliters of 1.50 mole per liter glucose solution is diluted to a final volume of 500 milliliters. How many moles of glucose were present in the original solution, in the final solution? Okay, so let's start with my original here. 30 milliliters of 1.50 moles per liter. So this is my volume. This is my concentration. This is my final volume. And I want to know how many moles of glucose were present. Okay, now if I look at my dilution formula, CIVI equals CFVF. I don't have moles N. There's no N in that formula, right? So I have to do a little bit more thinking here. If I want to figure out how many moles are present here in my original solution, well, I can just use my amount concentration formula, right? C equals N over V. That's got an N in it. I know the volume. I know the concentration. So let's try this. Let's solve for N. So to get N by itself, I have to multiply by V, N equals V times C. So my volume here is 30 milliliters. Now, for this formula, I need this to be in liters. So I take this 30, divide by 1,000, 0.03 liters. So we can plug that in here, 0.03 liters, multiplied by my concentration, which is 1.50 moles per liter, which gives us 0.045 moles. Okay, so that's how many moles were present in my original solution. This is my initial number of moles. Now it says, that's part of my question, right? That's part of what I needed to answer. It also says, what about the final solution? Well, if I want to find the number of moles in the final solution, I need to use C equals N over V. I don't know the C yet, though. So can I figure that out? Well, sure, I could use my dilution formula to figure out what my CF is, and then I could plug in here. Okay, so CF, how do I get that by itself? I've got to divide by VF on both sides. CF equals CI times VI over VF. So my CI was 1.5 moles per liter. My VI was 30 milliliters. My VF was 500 milliliters. Okay, let's see what my CF is going to be. So my CF will be 0.09 moles per liter. Okay, so let's see that. Then I've got my volume. I've got my concentration. I can solve for N here. So let's get N by itself. N equals V times C. My volume, got to turn that into liters. 0.5 liters times my concentration, 0.09 moles per liter. And that gives me 0.045 moles. So this is my final number of moles that would be present here. And you'll notice that it's the same, right, as my initial was. And hopefully that makes sense why that's the case, because I haven't changed the number of moles of glucose. I haven't added any glucose. I haven't taken any glucose away. So the number of moles of glucose will stay the same from the beginning to the end. Then when you're practicing these, most of them are pretty straightforward. You're going to use your formula, calculate whatever variable you're looking for. The ones that you need to watch out for, though, is sometimes we'll ask you not what a total final volume is, but how much water do I need to add? So if you look at this question here, how much water would I need to add to 500 milliliters of a 2.4 molar potassium chloride solution to make a 1 molar solution? It's not asking you what the total final volume is, although you'll need to figure that out. It's saying, how much water would I need to add? So you picture your beaker, it's got 500 milliliters in it. If it's got to get to some final volume, right? Who knows what that is? You can figure it out. Well, then how much water did you need to add in order to get to that final volume, right? That's what this question is asking you for. So just watch out for those. You'll have to do a little bit more thinking when you solve them.